Welcome back to General Chemistry. I'm going to show you something that is related to density, atomic radius, unit cell, and the molar mass of a compound. And we're going to be discussing about what kind of relationship do we have between them. So let's get started here. Well, what if we find out with an example? So let's do that. Let's think about tungsten, also called wolfram, that has a molar mass of 183.84 grams per mole. It forms, we can know this by X-ray analysis, a body-centered unit cell, and we can ask the question, what would be the theoretical atomic radius if its density is 19.3 grams per cubic centimeter? Well, there are many things we can do. For instance, we can remember that density is defined as mass over volume. We can remember that the molar mass would be the mass that the Avogadro number of atoms has in grams. So we know that Avogadro number is 6.022 10 to the 23, and this would be expressed in grams. So if I am talking about 183.84 grams, this means that 6.02 to 10 to the 23 atoms of tungsten weigh 183 grams, right? And the atomic radius, of course, would be the distance that we have, let's say, from the center of the atom to the border where it will meet with another atom over here. So that would be the definition of atomic radius, and we can remember that we normally use the unit picometer, which is about, well, it is defined as 10 to the negative 10 centimeters. Picometer would be 10 to the negative 12 meters, but remember that a centimeter is 100 of a meter, so that would give us 10 to the negative 10 centimeters per picometer. So let's have a look here to other relationships. So for instance, if we look at a picture of what a body-centered configuration would be, we have the atom in the center, and then we have the other atoms in each corner of the cube. And if when we look at the relationship here, we see that for this unit cell, we have two atoms that belong to the cell. So we have to take into account when we're looking at the density is that the mass of this cube is going to be two atoms, and then I have to multiply it by the molar mass, the mass of one atom. And that, of course, is going to be the molar mass, 183.84, divided by Avogadro's number, because this is gram, and Avogadro's number is going to be giving us the number of atoms that I have in that mass. So 0.22 10 to the 23 would be the number I have to do, and this would give me the mass of this cell, right? The other thing that we know is that depending on the shape of the structure of the unit cell, we have a relationship between the side of the cube. Let's say that I am thinking about this cube over here, then what would be the relationship between the length of the cube and the radius of that atom? And we'll see later on in class how it's kind of interesting to use Pythagoras' theorem here to find out. But in this case, when you have the body-centered cubic unit, you will have that L is equal to 4R over the square root of 3. So let's put these ideas together and let's find out what would be the radius of the atom there. So let's start. Let's do the following. We mentioned before that density is mass over volume. In this case, we know the density, we know the mass, so we can get the volume. We can solve for the volume, and we have then the volume is going to be equal to the mass over the density, and we have to then remember that the mass is going to be equal to 2 atoms per unit cell. I'm going to say unit cell. And then I have the 183.84 grams per mole, and then I have 6.022 10 to the 23rd. That gives me the value for the mass here, that I got something like 6.106 10 to the 20 negative 22 grams, right? So that would be the mass of the cell. And then when we look at the volume here, if we look at this equation over here, is going to be the mass, which is 6.106 10 to the 22 negative 22 grams, divided by the density, which we can find out in handbooks is 19.3 grams per cubic centimeter. So you see here I can use the grams cancel here, the centimeter goes cubic centimeters goes on top, so now I can say that the volume here is going to be equal to around 3.164 10 to the negative 23. I'm looking at my calculator, and of course this is going to be volume, so it's going to be cubic centimeters. So if I now remember that in a cube the volume is equal to the cube of the side length, then I can do the length is going to be the cubic root of the volume, right? So in this case, if I get the cubic root of this number, I get something like 3.163 10 to the negative 8 centimeters. That would be the length. Now, if I go back to this relationship here, I can solve for r, and I can say that r is equal to the square root of 3 divided by 4l. So I can bring that into this equation here and solve for that. So let me get some more space to write here. Okay, so we said r is equal to the square root of 3 divided by 4l, and remember that L we just find out is equal to 3.163 10 to negative 8 centimeters. So if we put that in there, I get that the radio of this is about 1.369 10 to the negative 8 centimeters. And if I remember that 1 picometer is defined as 1 10 to the negative 10 centimeters, I can change this one here and say that the radius is equal to 136.9 picometers. So you see, it's pretty straightforward, but of course it's a step-by-step process in order to see this. First we have to know what the molar mass is, what the density is. We can see what would be the relationship of how many atoms do I have in the unit cell. I can also know what would be the relationship between the side of the cube and the radius of the atoms here, and we have these tables to remember. And then of course we just do the algebra and we find what the radius is. And of course, if we know the radius and we want to know what the theoretical density would be, we can do exactly the same thing, just using the variables that we know and finding the ones that we don't know. So I hope that you find this video interesting. Of course, you can repeat it as many times as you want, and please ask me any questions if you have any. Take care. Bye.